I'd like to introduce, I think it's probably maybe one of the first here at 6, a hardware person on the Cloud Day. But I think it's actually very timely because with Internet of Things now, the cloud is reaching out to the physical world. And Iain Davidson from Freescale here is going to tell you about this.
Thank you, thank you. Yeah, so Bjorn, absolutely right. Iain Davidson from Freescale Semiconductors, so we're a chip company, headquartered in Texas. I'm from Scotland, not Texas. So yeah, Internet of Things for us is a huge, great opportunity. Of course, it's a whole collection of markets, whole collection of different devices, different applications, and they're all going to generate data. And as I said, a whole collection of markets and opportunities. Now, the footprint for Freescale on those markets, just in summary, right? So RF, analog components, sensors, small microcontrollers, large microcontrollers, automotive microcontrollers, communications and networking processors. All the way around the spectrum of those different scenarios we've painted there. So in automotive, driver assistance systems, connected car, vehicle-to-vehicle, vehicle-to-infrastructure type systems, radar type systems to help improve road safety. Within the home, wearable type devices for well-being, that sort of thing, and healthcare generally speaking. Of course, on the grid, improving the uptime of the grid and providing the communications that helps improve the fault tolerance of the grid, the industrial world, and then the networking world. So mobile and fixed infrastructure, enterprise type networks, like this little white box down here with Wi-Fi access point, probably has a Freescale chip in, I'm not sure, but probably it does. And then all the way into the data center, where we've got big data right in the middle. So top of rack switch was mentioned this morning, intelligent NIC type capability. So that's Freescale. We have this footprint. Now, when we talk to the clients we have in those areas, many of them are terrified about handling all the data. So they recognize they'll have, in an enterprise type scenario, you know, all this instrumentation around the buildings or the road infrastructure, the canal infrastructure, the grid infrastructure. They know that it's all going to be generating data. Some of them have done this already, and many of them have said, you know what, too much data, we don't know what to do with it, and they start to turn off systems because they don't know how to interpret the data. So we need help. They need help. Now, ignore the confidential comment. That was my mistake. None of this is confidential. So explosive growth in the number of connected devices. So somebody in this town said 50 billion by 2020. 50 billion by 2020, which when you look at it, you know, by, you know, per head of population, 6 connected things per person, no problem in subscribing to that. Now I'm going to start the talk talking about a gateway, and I'm going to end it talking about a gateway. And even if you have a gateway that only connects to 1,000 different devices, that's still 50 million gateways in the world. So that's interesting business for Freescale and for me. That'll become a bit clearer why I'm talking about gateways. So I don't have a cool squirrel, but I've got this surfer guy that I wanted to show who was really, really impressive. But as I said, the explosion in the number of connected devices corresponds with this explosion of data, the exponential growth. But of course, it has different challenges or different dimensions, different dynamics even. So there's a variety of different data. So clearly data that's generated by an electricity meter can be handled quite differently from data being generated from a radar system on a car that's trying to, you know, manage collision avoidance on the road, or, you know, an emergency type situation. The velocity, likewise, the velocity of the data from these systems can be treated differently. So the network and the data management systems need to be elastic, need to be reactive. These are the words we've heard already, which is great for me to hear. And then, of course, there's the volume aspect of it. Big data. Now, big data doesn't have to mean big iron or big machines. I wanted to share this real nice use case, the Astron, which is the Dutch Astronomy Institute. It's a government organisation that have been working on with IBM in Switzerland, in this case, so IBM Research. So it's a research project. And this is a microserver in the palm of your hand. and it's for this dome project. So what they're working on is a space telescope, effectively. So it's a square kilometre array of radio telescopes, all generating terabytes, exabytes of data every hour. And IBM made the observation that the cost, the very bottom bullet actually, the cost of moving that data from A to B, storing the data and then processing it, is actually much, much greater than the cost of this compute blade that's located at the space telescope itself. So their argument was, let's just process it right there. Let's not transport it to a data center. Let's bring the data center to the source of the data. Now, clearly, this square kilometre array space telescope is not an everyday type event. But when you consider, aircraft engines and cars and buildings are going to be generating, and even neighbourhood, a neighbourhood worth of metering data is still a lot of information, a lot of data that has to be processed. From an energy consumption point of view, most of the, IBM would argue, most of the energy consumed in a data center is just moving the data. It's not processing it, it's moving it from A to B. So move the processing, move the data center closer to the source of the data, to the enterprise, let's say. So managing the three words I use, volume, variety, and velocity. So I think most of us are engineers or have engineering backgrounds, and the font slightly shifted on this machine, so sorry about that. But there are different dimensions. I'm going to talk about security, which is why that arrow is a different color. But clearly there are other dimensions there. So software-defined networking type technology to help with manage the dynamic nature of how the access network, in this case, needs to behave, how the sensor gateway on the customer premise has to behave. The analytics is not, as I said, is not just a data center type thing now. It needs to happen not in the cloud anymore, but in the, let's just call it the access network perhaps, or in the enterprise itself. So hence the term, not cloud, but many people are talking about fog or edge computing. And at the customer premise, actually the connectivity is a big challenge. And that's not a data challenge, that's more of a problem for the likes of Freescale, but all the different connectivity type technologies, wired and wireless, and there's such an array of different wireless technologies that all have special qualities and are good at some things and not the others. So for me, these sensor gateways are really needed not only to, provide that universal connectivity, but bridge between the wireless sensor networks and the enterprise network, but also to provide a compute platform for analytics should you choose to do it there. And that is what people are trying to do. So we'll come back to that later. So I really wanted to talk about the security aspect of it. Now, just before we get into that, I mean, really the challenge that we are set by our clients and clients of our clients is this one. So they've got all these signals and all the data out there around their estate, let's say. They're frightened of the amount of data that it generates. And clearly they want to get to the point where it's not data they're dealing with, but information, and then in fact real knowledge. That's what they want to see. They don't want to be involved with the data. So that's been said already. I think we all agree about that. So data into information into knowledge, that's what we need to do. And it needs to be done closer to the source within the enterprise. So just, if you bear with me and we'll walk through this little scenario, this is the security aspect of it, or the trust aspect of it is, now coming at it very much from a hardware point of view at the moment, so as I say, bear with me, I think hopefully it will make sense. So let's consider this piece of meter, there's a meter, and it's generated this piece of data, and it moves through the network and into the cloud. That cloud application, it might, so they've got different clouds at the end. They might be different cloud applications. They might be different enterprise clouds. This is quite abstract. So that piece of data could then be shared from one application or one enterprise cloud to the other. And they will turn, there's a different colouring on there, it's maybe not showing up so well. But they will then turn that piece of data into some other piece of information, which could then be passed down to you, the user, on your smartphone, you, the subscriber to that information. You might then combine that with well, now both pieces of information you have, you might combine those two things. the camera there is generating another piece of information, and all of that gets passed back up to the enterprise cloud. It gets computed, it gets translated, it gets transformed into, you know, not individual pieces of metadata being combined into information and knowledge. And with that, as you go through that process, it increases the value of that information. That's the thing that can be sold. But for this to work, you need to be able to trust the data. And from the physical world, for us, we need to be able to authenticate IoT devices. Are they really what they claim to be? Or is it someone in that room with a laptop emulating thousands of sensors? What's to prevent that happening? And then once it's within the cloud, again, you know, you have virtual representations of these physical things. Can you trust those virtual those virtual pieces of virtual devices that you're subscribing to? So I know that's less of an issue, I think, for well, it's a big issue for Freescale, but that's not one that we can address naturally. But out in the physical world, we absolutely can, and not just at the devices, but on the networking boxes as well, from the sensor gateways through the layers of aggregation networks as we go. So the challenge of securing knowledge. So as I said, the Freescale microcontroller sensors and you know, gateway type equipment. So on the microcontroller side, I'd like to argue it's been solved already, in the sense that you have microcontrollers with embedded flash that can where we can validate the image that's in the embedded flash. We can monitor it so that we can ensure that it's not tampered with or changed. So what you burn into that flash at the point of production when you're building an IoT device can be protected. The gateway is different, and then once it gets into the cloud, it's different yet again. But I want to stick to the physical world for now, and let's have a look at the gateway. So it's not a white box. I've got a red box instead this time, and this is the box. Remember that it's connecting to this wireless sensor networks. It's also connecting on the other side to the enterprise, the carrier, or the cloud network. And our approach to this market is to partner with people, because we certainly can't do it all on our own. And as I said, it's not just about connectivity, it's also providing this platform for computation. So kind of standard slide that I'm just reusing today, but one of the boxes on the right hand side at the top, trust and security. So what if I was telling you that on a networking, in this case a sensor gateway, it might be an edge router, might be a service router or switch, that we can validate the software that's running on that node. So only OEM authenticated software can run on that box. We also have mechanisms to detect when the box itself or the software on the node has been tampered with. So we can have security checks on the debug port. We have runtime integrity checking that runs over areas of memory that you might want to protect. We have a fuse processor that can generate secrets that only authenticated software running on the device has knowledge of. And then, of course, virtualization technology, not necessarily unique to Freescale. In this case, this is an ARM Cortex A7 based box. So, you know, it has ARM Trust Zone as well, which complements that. So what we're starting to do there is really protect and authenticate the software running on that system. And once you've done that, you can then have it give it access to different secrets and different security keys, let's say, around the rest of the network. So just a little bit more elaboration on that. So I mentioned ARM Cortex A7, an ARM Trust Zone, and that provides, you know, an execution environment around the core and the cache and the memory infrastructure and the partitions that you have, software partitions you have running in there. But the Freescale Trust architecture extends that. So secure boot authenticates the software load running at boot time. It authenticates any firmware that you might want to add to that at runtime, let's say. Some software tamper detection. So not only do we have memory management units on the core and such like, we also have memory management units on the I/O. So an external host on a PCI Express interface or a remote interface on Ethernet, whatever, cannot be allowed to download data into an area of memory it doesn't have access to. and we have hardware there, enforcement of that. And the debug port, for example, can also be security protected. Now, if there are any violations on that, what can happen is, well, there are different measures that can be taken. You can shut down the device completely and render it useless, or you can generate alarms, or you can do nothing. It's all in your control. And then I talked about the hardware tamper protection and the secure networking. So on IPsec is commonplace, pretty much commonplace now. And in our architectures we offload that completely. So the encryption, the authentication, and the actual header, the packet construction, the new headers that get generated. We've got elliptic curve cryptography, which is becoming more and more in demand now in the industry. So trust and security. So we can do a certain amount of that from the hardware point of view, but the rest of the software system that goes around that in the larger enterprise and in the larger data center, we need help really to flesh that out. So a bit of a gift for you now, because I've talked very much about hardware, but gone are the days where we can just go around and give everyone a free board. We do more and more software as a company. That comes in enablement, is what this is, and also which comes in the form of commercial software from Freescale, but I'll stick to the enablement side of it. So, for people who maybe perhaps want a platform that has real devices, or let's say real devices connected to a gateway or a switch or a router type box, then this could be the kind of development environment that you might want to use. And remember, the security and the trust elements that I've been talking about so far. So a couple of microcontroller type nodes and a couple of real sensors, third-party sensors that we get from our partner network, all connected to the gateway. In this case, it's Wi-Fi. It could be Zigbee, could be 6LoWPAN, could be Z-Wave. We have all those capabilities. In this case, we're running MQTT messaging on it. Again, we're quite agnostic. That's just what we picked up. It came with those little Kinetis nodes. But the data flow around the system, well, there are at least two ways, which I'm showing there. There's the sensor data flow, which is up towards the cloud. But then, as I've mentioned before, increasingly what people want to do is make real-time and local decisions in their own enterprise, in their own system. And this is this is what we're providing here. So the control flow, if you like, is from the gateway, process the data and take action. Now you can imagine what's going to happen there. We're measuring CO2, it's a gas we breathe out. Too much of it, we start to get sleepy, especially just after lunch. I don't think that was planned that I'm on just after lunch, but there you go. That's the story there, and always grabs people's attention. So there are other sensors mounted on that thing, and we're going to turn the fan on at a certain point in time. So it's kind of gimmicky. It's a demo after all. But beyond that, you have the real building blocks of building up IoT type systems. And then from a software environment point of view, well, right up in the top corner there, you can see we've got the fan, the different sensors connected over different interfaces. Good old UARTs and PWM motor control type interfaces. Running the embed, so the ARM embed, RTOS is running there, and then the communications piece as well. It's good old TCP/IP effectively. But on the gateway itself, what we've worked with in this case, we've done a little bit of work with IBM. Had some help from them in terms of bringing up the Node-RED environment. So Node-RED is generating JavaScript, runs in Node.js, quite a powerful tool, and then connects over to the cloud using JSON. So this is a platform that we are putting out to universities, putting out to customers of ours, because we see this as a platform to develop IoT data-centric and data-type solutions that are local to the enterprise. Not everything has to be done in the data center. And what the industry, in our experience, what many of our clients and clients of our clients want to see is being able to get access to some of the data center type technology, but running it on embedded type platforms, whether it's a gateway or whether it's a microserver that sits in the corner of their room. So on one hand, hopefully I'm offering a gift in terms of this platform, but there's also a challenge there. There's also a challenge. Enterprises want these tools to run on equipment like this in their premise. They don't always want it to be in a data center. Now, I'm not sure about time. I think I'm a little bit ahead of time. But one of the, I know this is a bit cheeky, so apologies, and I'm going to talk about another event while I'm at this one. But hopefully you'll forgive me. So this is in Scotland. It's not in Stockholm. But so I've been talking. One of the things I've constantly referred to is what our clients and the clients of our clients want to see. And one of the reasons we get visibility of that is we talk to them. And this is an industry event here. We host not a Freescale event. You know, we don't even. Now I should check this. Yeah, Freescale isn't even listed in the number of speakers. We host it. We don't event it. You know, we're not selling anything we get there. But we're bringing together an array of different people that we have acquaintances with. Some of them are strong partners. Some of them are clients. Not all of them are. So people, as we go down here, you'll see Network Rail and the National Grid. So they're the people that operate our rail and grid infrastructure in the UK. They're the people that are saying, yeah, we want to deploy more and more instrumentation on our infrastructure. But what we've done so far terrifies us. You know, all this data, we don't know what to do with it. They need help. And the big data community is underrepresented in this forum. So it's in a few weeks' time, but clearly there'll be repeat events. And the rest of it, you know, the rest of the people are more technology-oriented companies that think they understand what the marketplace really needs. But actually, when you get into a forum like that, you realise that that's not always true. So, okay, Ericsson are going to come across. In fact, that's the Finnish guys are going to come across. IBM are there. The Watt's a startup. Baracht is a data analytics company local to us there in Edinburgh. ARM are doing some excellent, more and more these days, more and more software beyond their CPTU technology. And there's more. So, it's a great forum to learn what enterprises and industry is really, really wanting. So if you're interested, I'd be like to come along. Please do join that. As you see, I appreciate the invite today, because hopefully I definitely have given you something quite different from what you've seen before, and that's deliberate. It's disruptive, and it needs to be disruptive. We need to help one another. So enough from me. Thank you.